Ice Science 10. So we're going to talk about acceleration. We're going to talk about how to calculate acceleration. Now, acceleration, the best way to think about it is it's going faster and faster and faster. So starting at 0 miles per hour or kilometers per hour and 0 time, and then quicker, quicker, quicker. It can actually be in the other direction too, because it's really just a change of speed every second, essentially. So it could be slowing down. So, and then hit the brakes. Virtually all the questions we're going to do are going to be basically your classic acceleration, getting faster and faster. Of course, there's our formula that we're going to look at, so make sure you get your formula sheet. Let's share the screen and let's take some notes. Make sure you've got your formula sheet, your calculators. Make sure you get your notebook as well. With your formula sheet, of course, make sure to print the one that we provide, but you are going to want to make your own version of this as well. It helps you internalize what all of these letters and all of these symbols mean. You need to be writing them down, saying them as you're writing them down. But yeah, let's get underway with calculating acceleration. Got some pictures here. Gonna grab my marker and yeah, make sure again you get your calculator, your formula sheet. Get ready for grasp. You know, as we're solving problems, what is given, what is required. Do a little analysis, what formula, solve it, and then paraphrase. Always end with a sentence. But yeah, let's start with the title here, acceleration. And if you haven't already written this down, good time to start is right now. Basically, faster and faster. Each second getting faster. Now, when we calculate it at a set rate or an average acceleration, so it is actually an average. And I should try to spell the word out correctly. Average. And I think you can appreciate that if you think about it. You know, you stomp on the gas probably in the first little bit. The acceleration isn't as fast as, say, in the next second, but we do average it out over, say, if we go from just the classic 0 kilometers per hour to 100 kilometers per hour, and let's say we do that in a period of, I don't know, 8 seconds, right? So this is our km per hour. Now, of course, we would need to convert that into meters per second, but you know, I want to start with what we know or what we're comfortable with. And let's say this is over an 8-second period. Now, obviously, the acceleration wouldn't be even, right? Like in the first second, it's going to be a little different than in the third second. So that is why we get an average acceleration. And you'll see that when you look at the math. What we're doing is indeed calculating an average acceleration. You still just call it acceleration. You might see it sometimes referred to as average acceleration. So let's write that down, though. We calculate. So what we actually calculate. And should try again to spell that correctly. Great spelling day. An average. Acceleration. That's what the formula will give us. Some of the factors. Well, really, if you think about it, it's this difference right here between a starting point, and it doesn't always necessarily need to start at 0. Depending when the observer starts, you know, as you're reading the question, we could be, okay, we saw a drag racing car start at 0 and head off in a few seconds, get to this speed. Or it could be, you know, here's a cheetah coming by and measuring it from right, oh, this point here, you know, because it's already running, but we're watching it. But perhaps it's getting faster and faster as it goes after a poor little deer. Okay, so your key factor is the difference. Actually, there's a couple key factors, so let's do this one first. Your difference in your starting velocity. Yeah, get this down and kind of think about it though, right? Difference in your starting velocity and your ending velocity. And ultimately, and let's write the formula out. It is indeed considered a vector. So we've got the little vector symbol, A for acceleration, and then we're telling ourselves, okay, it's actually average acceleration. Okay, so basically velocity, and you can consider it speed, but we'll put the vector sign there. Velocity 2, so the ending velocity, so 100, subtract velocity 1, well, we started at 0. Oh, okay, so 100 subtract 0 would be 100, but still. And we'll get into some examples in a second. And time 2, again, in this case, it would be the 8 seconds. And again, this is in seconds. And this should be in meters per second as well, not kilometers per second. Time 2 subtract time 1. And again, in a classic example, we're just looking at a drag racer starting at time 0, but we might have a car that's already in motion and basically start tracking. That's an interesting looking car. Start tracking it at a certain point and just kind of measure its acceleration between a couple points of distance, and a couple points of time, right? Alrighty. So yeah, the second component is that second component right there, right? So the difference in your starting time, and you need to include these, and your end time in your formula. All right, well, let's just look at some problems and just get right into it. So again, make sure definitely you have your calculator, make sure you've got your formula sheet, because you want to go through the process of grasp of, take the given information required, do some analysis, and yeah, solve that. But yeah, let's flip that slide here, and let's just jump right into an acceleration problem. I'll call this model problem 3. All right, what's the acceleration of a drag racing car that can go from 0 to 200 kilometers per hour in 5 seconds? Holy doodle. Okay, well, first read it, but then, and get down your little summary here and write it out exactly as I'm writing it out. I always like to start with these two, given and required. Get those going right off the bat. Analysis is where we're figuring out what formula, but often that we can figure that out right here at required. And analysis leads right us to solve, and then of course we'll do the paraphrase. So a sentence. You have to set your questions up like this, and it's good to have a habit in any of your math and science courses. Find acceleration. I really, if I can, I like to start with required. Excel, it's not spelled right there. Ation. That is interesting. Okay, cool. And I might as well, if I'm that clear with myself, I might as well put down the formula right here, just so I've got it all in one place. Again, hit pause and see if you can kind of do it a little bit ahead of me, and or just watch and then try it on your own after I do it. Okay, so acceleration equals velocity 2, or basically the speed at the end, subtract the speed at the beginning. Okay. And time at the end, subtract time at the beginning. So from point to point, that's literally all this says. All right. Do we have velocity 2? Yeah, right there. We got velocity 2 and velocity 1. We take a look at that and, just make sure I'm correct here, right? We can go from 0. Okay, that's our starting point. There's our end point. Oh yeah, V2 is the end point. Now we probably should eventually convert this into meters per second, but let's just do it this way for now with the good old kilometers per hour. Velocity 1, in other words, at the starting point, yeah, 0 kilometers per hour. All right, time 2, the time at the end in 5 seconds. Ooh, put a little 2. Time 1, well, 0. Okay, it's a classic kind of drag racing question. Let's just jump right into analysis and solve because we do know the formula. That's analysis. We make sure we get the right formula. And we know we get the right formula when we put out the given information and we, basically can see what's missing is indeed acceleration. We're not sure about that, so let's solve for that. Let's plug in our numbers. Let's do our 200 kilometers per hour, subtract 0. Now that'll be 200, right? Anything subtract 0 is itself, but still we want to write it out just to get the process for ourselves. 5 seconds, subtract, well, let's put our units. Always put your units. 0 seconds. Okay, so 200 km per hour over 5 seconds. So get your calculator. 200 divided by 5, but I'm going to check this on my calculator. I think I can do that in my head, but 200 divided by 5. Yeah, 40. I was right. It's getting faster and faster by 40 kilometers per hour per second. Now there's a proper way to write that, and be careful right now. 40 kilometers per hour per second squared. This means it's not just going 40 kilometers per hour, because it obviously isn't, right? At the beginning, it was going 0, and then in 5 seconds, it's going 200K per hour. So every second, it's getting 40K quicker. Think about it this way, right? So after 1 second, so right at the 1 second mark, it's already going 40 kilometers per hour, right at 1 second. Well, at 2 seconds, it's going another 40 kilometers an hour faster. It's going 80, right? This is an incredible drag racer, by the way. After 3 seconds, it's going to be going, we'll add 40 to that, 120 kilometers per hour in 3 seconds. Well, you can see the pattern here, and you know where it ends up, and it should end up at 200, and it sure does. But let's just finish the pattern off. Add another 40 kilometers an hour, so it gets faster again. 160 kilometers per hour. Add another 40. Okay, here we go. We got our 200 kilometer per hour right there. And that's why we say per second squared. It's getting faster and faster and faster. Again, acceleration could also be getting slower and slower and slower. So over the course of 5 seconds, we go from 200K per hour down to 0, basically. So that could also be something. I don't believe we've got any questions like that, kilometers per hour. I won't right now convert this into meters per second, but you certainly should be able to easily do that, really, right? But for now, we'll answer it that way. We do a paraphrase. So the vehicle is now going, the drag racer's acceleration was 40 kilometers per hour per second squared. We'll skip writing it just in the interest of time here for us all. Let's try another practice problem. Read it carefully. Make sure you've got your formula sheet. And definitely hit pause right now and try it on your own using grasp, using given, required, analysis, and then we'll solve it. Oh, that's such a beautiful line. Okay, find acceleration again. A little a av. I got to take my second velocity, or speed really. Subtract my first velocity off, time 2. So again, just the difference between the velocity at the end and the velocity at the beginning, the difference between the time at the end and the time at the beginning. Let's get these values out. What is given in this question? Reached a speed of 19 meters per second. Okay, so it looks like we've got our velocity 2 right there. It reached that speed. Now we got our meters per second. We got the right From a standing start, we got our first velocity. If we're standing on its four legs, I guess, in a period of 2 seconds. Okay, there we got our second time. Time 2, 2 seconds. That's pretty impressive. Time 1, standing start, 0 seconds. Let's try to correct. Well, let's just do our analysis. That is indeed the formula that we require. Let's plug it in. Let's solve. "19 meters per second, subtract 0. Okay, again, we do know in our head that's just 19. And time 2, 2 seconds, subtract 0 seconds. Again, 2 subtract 0 is 2. So we just rewrite this as 19 meters per second, our ending speed, and in the course of 2 seconds, what's our acceleration? That is going to be 9.5. You type it in your calculator, you get 9.5 meters per second. It's acceleration squared, getting faster and faster, right? Because again, if you think about it, in the first second, the cheetah was going 9.5 meters per second. Then we add another 9.5 meters. That's why at the end of 2 seconds, it's now going 19 meters per second. If it continues at this rate, accelerating, then the next second, right, would be 9.5 plus 19. Let's see, do that in your head. 28.5, let me see. Let me check on a calculator. If I'm at 19 and then I get faster by another 9.5, yeah, 28.5. I think at some point it's going to stop accelerating. There's our answer. We'll put a little box around it. Yeah, let's do a quick paraphrase. The cheetah's acceleration is 9.5 meters per second squared. If you don't have that squared sign, we're not talking about acceleration. We would just be talking about a speed or a velocity. Well, let's do another one. Again, those exact 2 questions I just did with you, do them again on your own a little later, tomorrow or whatever. Same with this next one. As I pull it up, try to do it on your own first. Start by reading it. Okay, record set. Okay, a dragster. That's its final speed reached. Okay, and oh, there's our final time. So we've got a V2 there, and we've got a time 2. Okay, cool. Well, let's get this out here. Let's do our given. Let's do our required. Then the analysis and solve. Again, which formula we're going to use, and then just solve it. Just plug the numbers in. Hey, average. Okay, so acceleration. So it's going to be AAV. At this point, you've written this out a few times. It starts to internalize. You start to get comfortable with the formula. The more you write it out, the more comfortable you're going to get. Okay, so your velocity 2, subtract your velocity 1. You can just think of that as the speed, really. Time 2, excuse me, subtract time 1. What is our given? Sorry, excuse me, guys. Velocity 2, we do indeed have it. There it is, pretty exact, wow. 1.4508, that is a lot of meters, by the way, in a second, meters per second. You know, a football field is about 100 meters. This is like a football field and a half. Velocity 1 at its beginning, right? Well, it's a drag racer, so it started at 0 meters per second. Time 2, again, we've got it right there, 4.48 seconds. So sounds like it's pretty exact place here. Time 1, we're going to start at 0 seconds. Again, go right ahead and try to solve this on your own. You might have already paused it and you're just watching to make sure you got it right, so that's great. Just plug it in. Again, you're going to want to say, okay, acceleration. Tell yourself this is just a way to say acceleration. V2, so 145.08 meters per second, subtract 0 meters per second. I think we know what that is. 4.48 seconds, subtract 0 seconds. You can take note, we've only got 3 significant digits, so once we get our answer, we'll write out the whole thing, but then we will round it to 3 significant digits. This is indeed just 145.08 meters per second divided by 4.48 meters. Let's see this acceleration. Hit clear. 145.08 divided by 4. Typed in the wrong thing. Clear, clear, clear. Always clear your calculator lots. 145.08 divided by 4.48. I can do it. Yes, I can. Whew, it is it's pretty big here. It should come down to 32.38. Yeah, we're gonna definitely be rounding this, but let's just scroll my screen down. Come on, computer, do what I want. Attaboy, or girl. So equals 32.38. You don't need to write it all out, but write a bit of it out. 39. We only need 3 significant digits, so right there. So it's going to be 32.3 or 32.4. Do we round down to 0.3 or do we round up? Obviously, we round up. 32.4 meters per second squared. That's the acceleration of the drag racer. I'm going to skip writing the paraphrase. Again, it would just be, and you'll need to when you hand these in, but yeah, it would just be the drag racer's acceleration is 32.4 meters per second squared. And again, basically every second, after the first one, it's just going 32.4. After the second, well, that'd be 64.8, right? If you double that or you add another 32.4 to that, getting faster and faster and faster. That is all for acceleration. You now need to do the practice problems that we've got in the notes and get yourself ready for the assignments on acceleration. Okay, take care, Science 10.